Let's review how to graph a line. So when an equation is written into slope-intercept form, we call it slope-intercept form because it gives us the slope and the y-intercept. When we graph a line, we need at least 2 points on our line in order to make the graph. The y-intercept is a point. The slope is not. So we can start by graphing the y-intercept on the y-axis. Since our y-intercept is -3, I go down 3 and put my first point. Because my slope is 2, I'm going to use that slope to get future points. Slope is a rate, in this case 2/1, 2 per 1. So we're rising 2 and running 1. So from our y-intercept, we're going to rise 2, run 1, and then we have another point. Rise 2, run 1, and then we have another point. Notice I'm running to the right. Because my slope is positive, I want my line to go up from left to right. So I'm rising and running to the right. I could also go down and to the left, but I want to make sure that my line is going up from left to right since my slope is a +2. For the next example, my y-intercept is 2. Since that's a point on our line, I'm going to start at that point. Up 2, plot my point. The slope is -1/3, so this time I'm going to go down 1, right 3. Down 1, right 3. You only need 2 points to plot or to make a line, but I'm going to put multiple just to make sure my line is nice and straight. And I double check that my slope goes down from left to right because my slope was a -1/3. For the next example, it is not in slope-intercept form. The first thing I'm going to do is rewrite the equation so that it is in slope-intercept form by solving for y. So first I'm going to subtract 4x from both sides. So I have -3y equals -4x minus 12. I'm putting the -4x in front of the -12 since in slope-intercept form, the slope comes before the y-intercept. I want to put the x term, the term with the x, before I put the constant term. When I divide everything by -3 to continue to isolate that y, I have -4 divided by -3, which I'm just going to leave as 4/3. But because a negative divided by a negative is a positive, it's +4/3. So that's my slope. And when I take -12 divided by -3, I get +4. So my y-intercept is 4. That's the first point I'm going to plot on my graph. 4. My slope is 4/3, so I'm going to rise 4 and run 3. Well, when I rise 4, that's going to be off my graph. So it's an approximate, or I can go down 4 and left 3 to keep my slope positive. So always graph the y-intercept first, since that's a point, and then use your slope to get more points. Here are a couple more examples that are not in slope-intercept form. The next one we can't actually even get in slope-intercept form because there's no y. So I'm going to isolate the x instead. When there is no y, that means it's not possible to put it into slope-intercept form, and that's because our slope is undefined. So because our slope is undefined in this case, instead of starting with the y-intercept, I'm going to start with the x-intercept, which is -7. And slopes that have undefined, or lines that have undefined slope, are vertical lines. So this is the line x equals -7. It's x equals -7 because every point on this line has an x value of -7, like -7, 3, -7, 5, -7, 8, and so on and so forth. The next one can be written in slope-intercept form because we have a y. So I'm going to start by distributing. And then I'm going to work to isolate my y. So I'm going to add 4 to both sides. And then divide everything by -1. So when I rewrite this equation, I now have y equals -3x plus 2. So our y-intercept is the +2. That's where I start. That's a point on our line. And because our slope is -3, or -3/1, I'm going to go down 3, right 1, down 3, right 1, down 3, right 1, because I want my slope to be negative. I want my line to fall from left to right. In this example, we're going to write an equation of a line, and then we're going to talk about what it means to interpret the slope in the y-intercept. So the things we need to write an equation of a line in slope-intercept form is the slope and the y-intercept. Our y-intercept isn't super clear in this case. We don't know exactly what that number is. So instead of writing our line immediately into slope-intercept form, we're going to have to put it into point slope form first, because we do not know the y-intercept just by looking at our graph, but we do know points just by looking at our graph. But the first thing we need to find before we can do anything else is the slope. So I'm going to use our formula for slope and plug in our y's and our x's to find the change in y over the change in x. So 363 minus 231 over 5 minus 2. So we have 132 over 3, or 44. That's our slope. Now I'm going to choose one of those points to use to write the equation of our line into point slope form. So y minus 231 equals m, which is 44, times x minus 2. I could have also used the 0.5363. I'm going to go ahead and rewrite this equation so that it is written into slope-intercept form. And so we have a slope of 44 and our y-intercept of 143. So it's a good thing I did that, or I would not have known what that y-intercept was. I probably would not have guessed 143, maybe 150, but not 143. So with our equation, we can now interpret the meaning of the slope and the y-intercept. Our slope is 44, so our change in y over the change in x is 44. For this particular case, our change in y is talking about the cost, and our change in x is talking about months. And we're talking about a gym membership. So our gym membership costs $44 per month. Since slope is a rate, it'll usually be something per something else, in this case, dollars per month. Now let's talk about what the y-intercept means in the context of this problem. Our y-intercept is 143, and that's talking about the gym membership cost at 0 months. So the initial fee to sign up for the gym is $143. You have to pay that even before you start paying monthly. So you pay $143 for the gym, and then you pay another $44 per month is the context of that problem. The last thing we're going to talk about from this first lesson, 3.5, is how to solve a system of equations by graphing. A system of equations just means we have more than one equation. And so a solution to a system is the point that is on both lines. Solutions to a line are all the points on the line. So if it's a solution to the system, it's a point that's on all the lines involved. So to find out what point these lines have in common, we first need to graph the two lines. So starting with my y-intercept of -4 and my slope of 2, I'm going to put lots of points on here so I can have a nice straight line. And then for my second equation, I'm going to rewrite that in slope-intercept form by first subtracting 4x from both sides and then dividing both sides by -2. So I find out for this one that my y-intercept is 4 and my slope is 2. Well, I can tell just by looking at the equations that these two lines are going to be parallel because we learned already that parallel lines have the same slope. So because our two lines have the same slope and are parallel, they don't have any points in common. So there is no solution to this system. There are infinitely many solutions to the red line and infinitely many solutions to the blue line, but they have no common points. And so there's no solution for the system of the two lines. For our second example, I'm going to start by rewriting this first equation in slope-intercept form. I'm going to subtract the 3x from both sides and then divide everything by -1. So I get a y-intercept of 5 and a slope of 3. Put a few points on our line to get it nice and straight. My second line is the line y equals 3. That means my slope is 0 and my y-intercept is 3. Typically, what we would do after we graph our system is find out what that intersection point is, and that would be our solution. In this case, it didn't intersect at a perfect point. I know my y value is 3, so to know my exact x value, I would need to plug that 3 into the first equation to figure out what my x is when y is 3. Unfortunately, this one did not turn out very pretty, but we find out that that intersection point, my x is -2/3 and my y is 3. And so that's the intersection point. That's the point that both lines have in common, and so we would consider that to be the solution to the system.